Okay, so I'm going to stop you guys where you're at because there's some people that are on the right track and there's some people that are just like completely off. So I want to start off with the super basics. What the heck is factoring in the first place? Factoring is just rewriting the problem as a multiplication problem. So whenever you see something that says solve by factoring, eventually you have to turn it into this. That's our ultimate goal. That's what factoring is all about. Now, as far as the methods, there are like 6 methods. I didn't write up the GCF up there because it should be something you always check. You should be able to narrow it down just based on how many terms this has. This problem has 3 terms. So automatically, it's either going to be a simple ABC or a complex ABC. Which one is it? Good. So just as review, these are called ABC problems because they have 3 things, and the thing that makes it simple is this one. The simple has a 1 in front. Complex has a number other than 1 in front. So that's what makes it simple. Now, not only is it not a lot of work, but I honestly think that's why it's called simple. The work for it involves the very last number. So we take the last number, and we make the list of pairs that multiply to 6, but then they also have to add to 1. That means it has to be these 2. To get it to be a negative 1, 1 would have to be a plus and 1 would have to be a minus, which also takes care of multiplying to the negative 6. Now, eventually, that work I just wrote, that should happen in your head. If you can't do it in your head, well, then write it down. I don't care. Whatever it takes to get to the right answer. So now, this is a simple ABC. Once you got those 2 numbers, that's what you put into your parentheses. X plus 2 and x minus 3. As I was walking around, I saw some people trying to plus 6 over. So one big thing about factoring is these problems have to equal 0. So you should not move the 6 over. Now, we're still not done. As I walked around, some people had this, but then they never solved it. This is not solving. This is just factoring so far. Solving means actually find what x needs to equal for the whole thing to equal 0. There is a rule called the zero product property rule. And what that states is, if you have 2 things being multiplied and the result is 0, either the first one is equal to 0 or the second one is equal to 0. So essentially what that means is you're going to split it up into 2 separate problems. One of them is x plus 2 equals 0, and the other one is x minus 3 equals 0. To solve it, you just do the opposite. So if I subtract 2 from both sides, I have x equals negative 2. And if I add 3 to both sides, I have x equals positive 3. These are my 2 answers for that problem. Now, the reason, again, we wanted to focus on this is because on the final exam in May, these were one of the top 3 lowest scores we got as an Algebra 2 team. It's already happened in 3 chapters, and it's not going to go away anytime soon. Our tests have a review section from here on out. It's called Distributed Practice. This stuff is going to come up again, so you got to get better at it. Okay, so let me tell you where we're headed. We're going to start talking about polynomials. Polynomials just means that they have a lot of x's and they have some exponents in them. You're going to have to know how to do everything with them. Add, subtract, multiply, and the big one for this chapter is divide. You have never divided polynomials before. It's like for example, x squared minus 4 divided by x plus 2. I'm going to teach you how to do that 2 different ways in this chapter. But in order to do these things, you have to understand the exponent rules. So that's what today is all about. Now, my claim to you is you don't really have to memorize any rules. You just have to know what exponents mean. If you can understand and comprehend what exponents actually are saying, you don't need to memorize any rules because they'll all take care of themselves if you just do it the long way. So the way I'm going to approach this, I'm going to show you the first problem the long way, and then we're going to come up with the rule, which is actually the shortcut. So let's think about this first one. What does 5 squared really mean? Okay, so that problem right there really means 5 times 5, and then the other one says times, oh my gosh, this is all misaligned. It says 5 times 5 times 5 times 5, 1, 2, 3, 4, 5 times 5. So the first one says there's 6, and the second one says there's 2. Or I said that backwards, I think. First one says there are 2 5s. Second one says there's 6 5s. So how many 5s are there altogether? Oh, yeah, be careful. So this is 5 to the 8th power. Now, guys, you're gonna experience large exponents. I don't expect you to write out, like if I told you 5 to the 20. I don't expect you to write it out 20 times. That's ridiculous. And that's where the rules come in. Is there a faster way to get to 5 to the 8 using the 2 and the 6? There it is. That's the rule. So, this is another big thing here too. Some rules look the same, or some problems look the same. If you multiply 2 numbers with the same base, so first of all, what the heck is a base? A base is something that the exponent is sitting on. So the reason why we're allowed to use the addition rule, the reason why we're allowed to use it in this problem is because both of these have matching 5s. If they don't have matching 5s, you cannot add their exponents.
If the numbers don't match, you can.
Well, yeah, not just numbers either, letters too, because we use letters in place of numbers. So, for example, this next problem says y4 times y3 times y. It's the same rule. You see the letter repeat a bunch of times. So we have to add them together. So what would that add to? Good. It's going to be 8 because here's another fact you need to know. Everything has its own exponent whether you see it or not. You don't see it, it's a 1. So altogether, this ends up being y to the 8th power. Now, I want to re-emphasize this. They have to have the same base in order for you to add their exponents. So take a look at the next question. I got a 7 and I got a 6. Can I add their exponents? No, they're not the same. So when they don't match, you can actually just multiply them. 7 times 6 is 42. Then I have y to the 5 and y. So altogether, y to the 6 would be your final answer. That's your final answer. Now, later on, I'm going to give you some additional things to watch for, because there will be some times where, say you have like a negative in the exponent, and you're not allowed to. You're supposed to fix those. So I'll teach you in a few minutes how to fix those. You guys do that last one real quick. I'm going to give you 30 seconds. The first part. First part's like negative 15, right? What'd you get for the rest? X to the 3rd, y to the 13th. Good. So guys, the first rule is if you're multiplying things and you see bases repeat, you have to plus the exponents. If they don't match, you just times them like normal. Now, for some of these rules, there are some pretty basic rules, and then at the end, I'm going to show you basically the same rule just applied to more stuff. But, I mean, think about this. The first rule said if you multiply, you really actually add the exponents. What do you think we have to do if we divide? Yeah, it's just the exact opposite. Let me show you why this happens. I told you, I'm going to show you the long way for everything first, and then we'll come up with the rule after. Same thing as before. If you're dividing and they have the same base, that means the stuff matches, then you can actually use a shortcut for their exponents. So let's see where this comes from. Y to the 6 means there's 6 y's on top. 1, 2, 3, 4, 5, 6. And then you have a single y at the bottom. Now in a fraction, what can you do with your stuff if it matches on the top and on the bottom? Yeah, you should be able to cancel. So if I cancel this one with this one, look at what it leaves me with. It leaves me with y to the 5th power. So using that long, drawn-out way of doing it, you can actually come up with the actual rule for the shortcut. The shortcut is, that has a 1, don't forget, all you have to do is subtract. If you subtract the top minus the bottom, that's your answer. So this would be the subtraction rule. I don't know why I put subtraction. That doesn't make sense in the sentence. It should just be subtract. So when you're dividing, subtract. Oh, you know what? I'm going to do this. I'm going to put this on the side. Subtract from top to bottom. Use the top exponent first and then minus whatever's on the bottom if you're going to use the subtraction rule. So emphasis again, it has to be the same base in order to do this. This is a 6, this is a 6. So you're allowed to do this. We can write a single 6 and then subtract from top to bottom. 13 take away 2 is 11. So there's our answer. Now guys, anytime you have stuff that doesn't match, because remember this is all about that base. That was stupid, I'm sorry. Yeah, I'll never do that. The third hour's not going to hear that. That was horrible. So when we use these rules, it has to match. The bases have to match. If they don't match, just treat them like normal. For example, the 10 and the 15, they don't match, right? So we're going to treat it like normal, and we're just going to reduce it. If I reduce 10 over 15, I think it's 2 over 3. And then we got some A's. I got A on top, A on the bottom, so I can subtract them top to bottom. 7 take away 5. And if you're going to use the subtraction rule, the answer always goes on top. So it's A squared. What happens to the B's? Yeah, they basically cancel each other. So the B's go away. Now I'm going to show you something, because this is an actual rule. I'm going to show you something about the exponent of 0. Because, I mean, technically, we could have subtracted 9 minus 9, and then we get 0. But then all of a sudden the B's go away. Here's why that happens. Oh, the reason why that happens is because of what the problem actually means. So if I was going to use the subtraction rule, this is really going to give me 8 to the 0 power. But just think about what that problem means in the first place. Doesn't that actually mean, let me go off to the side over here, doesn't that actually mean 64 over 64? So what is 64 divided by 64? You're all fired today. So guys, when you have the same exponent, you subtract them, and when it gives you 0, it's the same as that division problem. So this right here, it actually just gives you 1. Now do me a favor, turn on your calculator right now. Type in any number you want. I don't care if it's a decimal, a fraction, a square root, a positive, a negative. It could be a billion if you want to type that in. Raise it to the 0 power and look at what happens. For every single one of you, if you raise it to the 0 power, the answer is always going to equal 1. That's the 0 exponent rule. Everything that has an exponent of 0 turns into a 1. So check this out. Isn't it true that this entire parentheses has an exponent of 0? So basically everything inside is going to turn into a single 1. Say that again. Yeah, so you got to be careful. In the class that just left, everyone thought the final answer to this was 5. And I was like, how'd you get 5? And he said, well, Tara, you said 0 turns to 1, so it basically cancels. And they canceled the whole thing. Well, here's the problem though. What does the 0 belong to? It only belongs to the x. That 0 doesn't go with the 8. The 8 has its own number. It's a 1. Everything has its own exponent. So really the only thing that's going to go away is the part that has the x. And it's not that it's going away, it's turning into 1. But 8 times 1 is 8 anyways. So this problem actually turns into 8 plus 5, which is 13. So when you guys give me a final answer, I should never see a 0 as your exponent. That needs to be simplified. Now right now, as of right now, there's only 2 things you have to know. You have to know that when you multiply, it's really add the exponents. When you divide, it's really subtract the exponents. There's really only 3 rules, and then the rest of them, they're just sort of a different version of that same rule. So let's turn to the next page. I got a couple more to show you. Now, I want to use the rules that we know so far. So if we look at this problem right here, what am I supposed to do with those exponents? Am I supposed to add or subtract? Okay, good. Hey guys, another just little trick that I use to remember. To me, that line right there, it looks like a subtraction line. That's how I kind of remember that. Now, I also have to do it from top to bottom though. So 2 take away 5 would actually be a -3, but here's the bad thing. In this stuff, you're not allowed to leave your exponents negative. So there has to be a way to fix it. Now I'm going to show you like how this rule happens, where it comes from. Let's think about the long way of doing this. B squared means there's 2 b's. B to the 5 means there's 5 b's at the bottom. We discussed earlier that they cancel each other. So that cancels this. That cancels this. So look at what I'm left with, and look at where they're left. There's 3 b's left, and they're at the bottom. So this problem right here, you can actually turn it into b to the 3 at the bottom, and on the top we just put a 1, because it can't be blank. Now I'm going to show you the actual rule. It says for anything raised to a negative exponent, place the power in the denominator to rewrite the power with a positive exponent. Positive. I stuttered when I wrote it. Positive. There we go.
Just curious, is there a reason why we can't?
I've always wanted to say this because I don't have kids of my own. It's because I said so. I'm just kidding. I have no idea. I know that the only time we usually work with negative exponents is in scientific notation. I don't know the real reason why we have to fix them. But that's just a rule that's understood when it comes to exponents. We should always fix them when possible. So guys, if you guys look at the example below, this says 2 to the -3. I need to fix it. I can't leave it like that. So what I need to do is I need to switch where it's at. I need to put that down at the bottom, and in doing so, that turns to a +3, and then the top just turns to a 1, because it cannot be left blank. The next question. If I give you a problem that has an exponent, because remember guys, today is all about exponents. This exponent is negative, and it's not allowed to be negative. So I have to flip it. So that goes down to the bottom, and in doing so, it becomes a +3, and then this stays as a -3. Now here's the reason why. The rule I told you about not allowed to have negatives only applies to exponents. The base can be whatever it wants, but the exponent just can't be negative. And then our top would be here. Just be a 1. I want to make up one more, just because we need to talk about this, because you will see this. Let's say I have a squared b to the -3rd. The rule is you are not allowed to have a negative in your exponent, and when you do, you need to fix it. That is exactly 100% correct. Over here, I told you that if you saw a negative, you put it at the bottom and it turns positive. If it's already at the bottom, you put it up and it turns positive. So this now joins the a squared and becomes b to the +3.
They all switch places?
We only fix negatives. The only one that's negative is this one, so that's the only one that needs to move. So far, guys, there's really only two rules. Adding and subtracting. The stuff that I showed you, these last two, those are simplifying rules. So I'm going to show you the last rule. Rule number 3. Here's what you think about. Like, the exponent on the outside, it actually means how many copies you have. And I want to do the one on the right because the number is smaller on the outside. So that problem means there are 4 sets of parentheses. Each of them have a -3 on the inside. Now, this now turns it into one of our other rules, though. If I have 4 of these y's, what can I do with their exponents? I just add them up, right? So this right here, this would give me y to the -12. But my claim to you is the rule is actually the shortcut. Instead of writing it out, we could use a rule with those two numbers to get to -12 a faster way. Yeah, the rule is multiply. Now guys, the thing to note, and you might want to jot this down in your notes, we don't have more than one y in this problem. We only have one. Not only that, I don't know about you guys, but when I look at this, when I see a 3 and then a 4 immediately after the parentheses, to me that means multiply. That's how I remember it. Now, that's what I was about to say. One other thing, we got to fix this. We can't leave answers like this. So using the rule from before, we would have to make it 1 over y to the 12th. So now using the shortcut, Desiree, what's this answer going to be? Are you ready? What's the answer? Someone help her out. How did you get that, though? Because that's what I'm more concerned with. When it looks this way, you have to multiply. So this gives us x to the 16th power. Now, that's the last new rule. Everything else is just a different version of the stuff you already know. So take a look at this next one. To me, this is the same as this. To me. The only difference is down here at the bottom, it's got more stuff inside. But it's the same exact rule. So what you're going to do is you're going to figure out the power of each factor first. Because remember, the stuff that's on the inside, each part has its own exponent. So in this example, how many exponents are on the inside? I didn't say how many can you see, I said how many are there? There's not 3. There's actually 4. There's the 3 that's showing, there's the 1 on the 4, there's the 1 on the y, and then there's the 1 on the z. Now, because this is the same rule as the one before, we multiply. So we multiply all 3 of them. So we're basically going to distribute. Whoa. So in this problem, we end up with 4 to the 3, x to the 9, y to the 3, z to the 3. Again, to me, those are the same exact rule. I don't see any repeating stuff. When you see the repeating stuff, that means you either have to add or subtract. If they're at the same level, you add. If they're at different levels, like a fraction, you would subtract. Next one. Each one has a 1 on it, so this is 7 to the -2, x to the -2, and y to the +4. Then we have to fix it because we know the rule about not having negatives. So this one has the negative, and this one has the negative. So those are the two that need to move to the bottom. 7 squared, x squared. The y to the 4th is positive, so it stays on top. And you guys already know this, I'm sure. You guys are aware this is all over 1, right? That's why I'm saying the y4 stays on top, because currently it is on top. Okay, the next one. Oh man, I see a 0. What does it mean when there's a 0? It turns to a 1, but 1 times anything is the other stuff, right? So you can just kind of ignore that one. We don't need that. put the 1 on the 6. So that's got 3 problems to distribute to. 6 to the negative 2, x to the negative 12, and then y to the negative 14. Well, dang it, all 3 of them are negative. So that just means we have to fix all 3. So all 3 of them go down to the bottom. X to the 12, y to the 14, and then on top we have a 1. Can't leave it blank if you can't put 0, so we just put 1. And I mean, really, you guys, that 1 is not magically appearing. Everything technically is being multiplied by 1. We just don't ever write it. That's where that top 1 comes from. Now, guys, if you know that rule, well, then you know the one that's on the last page also. Why is this all written on? I don't know. So in this page, the only difference. So first of all, let's talk about how it's the same. It's the same because it's still about parentheses with an exponent on the outside. The only difference is now you have fractions. The rule still applies. Think about what we did on the last one. When I stuck a bunch of stuff, didn't we just distribute? We're going to do the same thing here, except we're going to do it to both the top and the bottom. So you're going to raise, what does it say? For any numbers a where b is equal to 0, quotient a and b is raised to a power, raise both the numerator and the denominator to the given power. So guys, the way I think of this, there's really only 3 rules. There's the one where you have to plus them, there's the one where you have to minus them, and there's the one where you have to times them. This stuff is just a variation of that. This just has more stuff inside, so we still times. So this problem, it would be 3 to the 2 and 5 to the 2 on the bottom. I mean, technically, every number should be simplified, but I've been lazy. Bless you. I've been lazy for these notes because I'm more concerned about you knowing the rules. Yeah. I have to check because I don't know what big ideas math is going to do. I think it's going to make you simplify, so maybe we should simplify. So I'm going to say from here on out, you should never see numbers with exponents. They should all be worked out. So that's 9 and 25. So again, in this problem, just because it's a fraction doesn't change how we do it. The fact is you have parentheses with an exponent outside. That means multiply. So you do it to everything. 2 squared, a to the 10, b to the 14. And then we have the number with the exponent, so I'm going to fix that. 4, a to the 10, b to the 14. This one's kind of the same. And guys, I'm going to tell you right now, the biggest mistake people make is they completely ignore that one. Or they try to multiply 3 times 3. You're supposed to multiply exponent stuff. So it's actually 3 times 1. So 3 to the 3rd, a to the negative 12. And on the bottom, you have b to the 14. Oh, just kidding. 21, but it's 3 times 7. I don't know where I got 14 from at all. So there's 2 things we have to fix. You can't have this, so that needs to move down to the bottom. It becomes a positive when you do that. And the second thing I have to fix is 3 to the 3rd. Guys, 3 to the 3rd is not 9. It's 3 times 3, and then times another 3. So that's 27. And then your last one, I mean, again, straightforward, guys. You got an exponent on the outside, you times it to everything on the inside. Exponents only, though. So a to the 12, b to the 30, c to the 66. Everything turned positive there, so we don't have to fix anything. Also, notice this. Do you guys realize we don't have any repeating letters in our answer? Our final answer should not have repeating letters because if they're repeating, you either need to add them or subtract them, depending on where they end up in the fraction. If they're on the same level, add them. If they're on different levels, subtract them. Now guys, as boring and as dry as that was, you really have to know this stuff. I'm going to show you a question similar to the one on the test. And this one right here really tests whether or not you understand the rules. So this is the answer. This is the answer, and I want you to check off all of the ones that would give you that result. How many check marks would we have here? Yeah, there's only one answer. It's this one. This one right here. This is, and that's where studying comes in. You just have to memorize. When you have parentheses and there's a number on the outside, that means times. That's actually 64. Right here, parentheses, number on the outside, that means times. So that's your 16. And then if you see it twice, you have to add that. So that's actually x to the 8. So that's what it comes down to. You really have to know what the rules are. I showed you two different ways of doing everything. You can either write it out the long way, or you can actually use the rules, which I refer to those as the shortcuts. Now, you guys picked up the homework packet, right? There are some silly questions on there. Look at number 17. It looks big, scary, and intimidating. Yeah, but look at the exponent on the outside. It's a 0. That basically turns everything to an exponent of 0. So ultimately, your final answer would just be 1. Now, there are also questions on there that are way more involved than anything we'll do on the test. So I adjusted the assignment. These are the only questions I'm going to have you do. This is the new stuff, the exponent rules, and this right here is factoring. Because we're always going to review that every single day. And the rest of the time is yours to practice and work on the assignment and get help.